Alright, for the Lagrange interpolation techniques, so it's will similar to the Newton divided difference in terms of it have a general form that we can use this formula for approximating a function that describes relation between data points, and we will start with the linear interpolation. And then we go for the quadratic interpolation. And higher order polynomial. Okay. So if we start with the linear interpolation, what we want two data points, which is x0, y0, x1, y1. And if we have two data points, we would create a function. Okay, where is x0? Where is x1? So we create a linear function. So this function will represent by fx equal to ax plus b. Okay, so at x equal to x0, if we substitute to this function, we get fx0 thus equal to ax0 plus b. Okay, this is equation 1. And also at x equal to x1, here is f of x1 equal to ax1 plus b. This is equation 2. Okay, and if we try to subtract equation 2 by equation 1, so from here we get fx1 minus with fx0 equal to ax1 minus x0, right? And from here, okay, from here a is equal to f x1 minus f x0 divided by x1 minus x0, right? And this is equation 3. Of course, from fx equal to ax plus b, if you substitute equation 3 to this a term, we get at x equal to x0. Okay. Here is fx0 equal to a, which is fx1 minus fx0 over x1 minus x0 times with x0 plus b, right? So from here, b can be written in terms of fx0 minus fx1 and fx0 divided by x1 minus x0 times with x0. Okay, this is the b term. And of course, we need to rearrange the formula so we can get like a general form. Okay, so after we rearrange A and B, finally we get fx equal to fx1 minus fx0 divided by x1 minus x0 times x plus fx0 minus, this is actually the A term, and plus B, so this is like fx0 minus fx1 minus fx0, right? And divided by x1 minus x0 times x0. Okay, this is like a B terms, the one that we get, and then we try to rearrange this form, and finally what we get is x1 minus x over x1 minus x0, okay, times with fx0 plus x0 minus x over x0 minus x1 times fx1. Okay, so this is assumed to be the L0 of x function, and this is assumed to be the L1 of x function. So the general formula would represent the function fx in terms of L0 x times fx plus L1x plus times with fx1. This is a formula, or we can write in the summation of xi, fi x fxi, where I equal to 0 to n. Right. Okay, and from this equation, L0 x equal to x1 minus x over x1 minus x0. If you plot the graph between x and L, so at x equal to x0, okay, it means that you get x1 minus x0 divided by x1 minus x0, so you get 1 here for L terms, right? And if it is at x1, it is at x1, x1 minus x1 would equal to 0. So the L0 function would represent by this line, right? So from this function, what you see is that for L0 of x, it will equal to 1 if x is equal to x0, while it will equal to 0 if x is equal to x1. Okay, this is the criteria for L terms, right? And for L1x is actually be represented by x0 minus x over x0 minus x1. Okay, and if you plot this function to this graph, okay, at x equal to x0, x equal to x0, so it is x0 minus x0, you will get 0. And if x equal to x1, so you get x0 minus x1 divided by x0 minus x1, you get 1. So L1 function will look like this line. This is L1x, and it will be equal to 0 if x equal to x0. It will be equal to 1 if x equal to x1. Okay. So after you know the L function, you can use this fx equal to L0 fx0 plus L1 fx1 to approximate y at a certain x. Okay, so let's see example. And here we will see some example. So from this example, I will use the same data points that we did in the Newton divided difference. So at x0 equal to 2, you get y0, which is equal to 0.2239, and x1 equal to 4, we get y1 equal to minus 0.3971. And if you would like to know at x equal to 3.2 what y should be. Okay, so from here you can approximate fx, right, from the function of L0x times fx0 plus L1x times fx1, right? And from here, L0 x can approximate from the function of x1 minus x over x1 minus x0. And also L1x can be computed from x0 minus x over x0 minus x1. So at x equal to 3.2, so what you try to do is you determine x equal to 3.2, right? So L0 will equal to x1, which is 4 minus 3.2 divided by x1, which is 4 minus by x0, which is 2. Okay, this is L0. Okay, and also L1, it is the x0, which is 2 minus 3.2 divided by x0 minus x1, which is 4. So it's here. Then what do we get? We get fx equal to this term, right? So it is like 4 minus 3.2 over 4.2 times with fx0. fx0 is 0.2239. So this term is multiplied by 0.2239 plus L1 times fx1. So L1 is actually this term. So it is 2 minus 3.2 over 2 minus 4 times with fx1. fx1 is minus 0.3971. Right? And from here, you can get f at x equal to 3.2 will equal to minus 0.1487. This is the answer for the approximation by the Lagrange interpolation function.